Hi, Maurice. So is Maurice pronounced perfectly or not?
You pronounced it perfectly. Everybody pronounces it perfectly in different ways.
Ah, okay. I thought this is Maurice or Morris.
No. Nobody ever says Maurice. Well, often people say Maurice because they're
Maurice.
American or they're French or because they want to wind me up.
Okay.
But I'm really okay with anything.
Okay. So now the most important question, as you probably know in my podcast, is what was your first computer?
My first computer was was something called a Shelton Signet.
Wow.
It was a CPM machine. I know.
Shelton Signet.
Shelton Signet. Well, in those days,
It sounds like a secret weapon. Something, like a ninja stuff or something like this.
let me have a look and see whether I bet not even the internet remembers Shelton Signets. I don't think I've said those words. I've even thought those words for like 30 years.
Mm-hmm.
I got this computer in the 1980s.
1980s?
In the 1980s, yes, absolutely. It was, and it was, I'm frustrated to think how much money I spent on it. It was £3,000.
Oh.
£3,000 in the 1980s. That was a lot of money, and how often I think if only I'd have bought Microsoft.
A pounds. This would be like dollars right now, maybe 6,000 more, right?
Well, in those days, Well, in those days, the exchange rate was quite different. So you probably
yeah, but you're translating, the inflation or whatever. So the 3,000 back then would be more like 6,000 now, right? $6,000.
No, far more than that. I could look it up, but I mean, it's like tens of probably. I don't know why I had that kind of money, but it would probably be well into five figures. Well into five figures. And CPM. CPM was an operating system that was popular then. And I think it actually carried on into the.
I think the Schneider computer, because it was German one, had the same CPM. I think there was Schneider and Commodore. No.
That was a proprietary one. CPM was kind of a standard. I'm looking on the internet. The internet does not remember Shelton Signets, but if I look to see about CPM, I'm sure it will remember that. A disk operating system. A short history of CPM. It was an 8-bit operating machine which started in 1972.
So you are late to the game. So in the 80s,
Yeah, absolutely.
So you're okay. So what you did with the computer? I mean,
the main thing I remember, I probably played with it, but the main thing I remember doing it at that time, I was teaching in a. It must have been. I was teaching in a polytechnic.
Okay.
And
Which one? Where?
In Wolverhampton, in England.
Okay.
It's all the polytechnics got turned into universities, so it's now Wolverhampton University. And I think they had the same. I'm confident they had the same machines there. It was always my policy for quite a long time to have the same machine at home as you had at work, because then you could steal the software. And software was incredibly expensive at that time. Really, really expensive. So you had to. So I mean, something as ordinary as a word processor or a compiler. I mean, compilers cost a lot of money. My memory is not very good for all this sort of thing, but I think it was like.
What did you teach? Programming or something like this?
Yeah. I was teaching.
Which programming languages back then?
I'm trying to remember, but I think Pascal was the was the language that we were teaching at Wolverhampton. I'm pretty confident.
Were you a professor back then, or?
I was just an ordinary lecturer.
Okay.
Just an ordinary lecturer. Yeah. So. I don't know what more to say about that. I'm trying to pin the date down in my mind. But
it doesn't matter. But what just interests me now? Why you bought the machine and what you did with it?
Oh, that's right. Why I bought the machine. The main thing I remember doing was writing a membership system for a political campaign I was involved with at the time. Campaigns for nuclear disarmament were a big deal in the early 1980s. And we had quite a large membership in the area that I lived, and I had this notion that I would write a membership system for it, and as far as I remember, I did, but I don't know how well it worked in the end. That was I was like that was an application that came to my hand, And it seems obviously odd now that you couldn't just take one off the shelf, but nobody had such things.
Yes and no. So you can. There are still startups which care about. I think one is called even Memberful or something like this. So there are new startups who just care about membership. So there is nothing. I mean, there's nothing. It is still room of innovation. This is to innovation. This interesting part.
I guess so. I mean, currently, I'm the community that I'm involved in is using a membership system, which is actually quite comprehensive. I mean, it's sort of like a commercial package, or it is a commercial package, I guess, but it's angled towards voluntary organisations and so on.
Mm-hmm.
And that started in the same kind of way. Somebody wrote a membership system for their church, I think, in New Zealand. Mm-hmm. And they kind of grew arms and legs, and they thought, well, other people could use this, and now it's a kind of, I guess, a kind of a pretty fully featured membership system which tracks voluntary organisations and charities and community organisations and that kind of thing.
Cool. So okay, you are the first guest, which started, full gas with with computer and for teaching. Actually, usually the story is I bought a computer, I enjoyed the gaming and played with it, and then I discovered DOS or scripting, and then I became a programmer. So now the question is how you could. How you learn programming without having a computer?
Right. Well, yes. So the point at which I first encountered programming was I was doing a science postgraduate degree, and this would have been the early 1970s, so a decade before this.
Which science? Which kind of science?
I was a chemist, but it was kind of chemical physics.
Okay.
The subject I was studying, which was then called nuclear magnetic resonance, but I thought I really enjoyed it and I was quite good at it, but I thought it didn't have very much promise because it was I thought it was basically a lab toy. It was so crude. That later became they later renamed it as nuclear magnetic resonance. Magnetic resonance imaging. Mm-hmm. You can see how accurate my assessment of its promise was. Mm-hmm. I totally got that wrong. Well, anyway, to analyze the spectra from the output from MRI, you have to do fast Fourier transforms. You have to do Fourier transforms on the spectra, and obviously you had to be able to program to do those. And although we had fast Fourier transform programs, there was still a lot of post processing had to be done. So I learned Fortran to do that. And
I have to ask you something, because the Fourier transforms, the fast Fourier transforms. So during my university, we had some assignments, and we had to use the NAG library. You remember that?
Vaguely.
Yeah. And I never will forget it, because we had to pass arrays from C to NAG, which was probably Fortran. Mm-hmm. And the professor, maybe he enjoyed, to generate some pain, and he never taught us that the arrays are sorted, or the indices in the library are other ways around. So the first is the last. I don't know why it was like this. So it never worked. And after a few days, the prof said, "Okay, you have reorder the array." I said, "Okay, you could told us, 2 days ago, not now." And this was like assignment from hell. The entire NAG, as I remember, and the C and the entire thing. And the cool story is, it never worked in my case, but I knew the outcome. I don't know why, but I knew that. And I wrote a really complicated C program, which didn't work. And my hope was that if the professor looks over my shoulder, it's like, okay, he does something. Mm-hmm. And the constants, the results I put on the very far right, so they couldn't see, the results. So the result was perfect, but the program didn't work, because I just picked the constant and printed, and then I passed, the assignment. But this was the NAG and the fast Fourier transform. But I have to say, now I'm really interested in Fourier transforms. And back then, I had no idea why it is useful, I studied computer science. Mm. And this is like, here is the Fourier transforms, like, why the hell we need that? So, and now I'm really interested, because this is very, how to use computers for mathematics for me right now, right? So you can use, the Fourier transforms and how to call it if you can, calculate an area under a graph. This is a specific, you know what I mean? In mathematics, there's a specific term for it. Sure. Differential, right?
To integrate the
integrate, exactly. This is a really interesting, but back then I couldn't imagine. So sorry to interrupt you.
No, not at all.
Yeah. And okay, cool. So you had to use FFTs, and this is how you start the program.
Well, I don't remember now. I don't remember now exactly. I mean, I remember more the experience of programming in those days. I mean, there's probably not that many people left around who can remember typing out punching out your program. You would take your program on coding sheets to the punch room, and they would and they would punch the cards that corresponded, one card for each line of the program, and you put these in a tray, and you would pass the tray through a rack of pigeonholes. Pigeonholes with no backs. They would take the operators, the computer operators would take your tray of cards away. They would run them through a card reader, and you would come back a few hours later, and you would get some line printer paper with the results on, and you could tell immediately whether it was good news or bad news by just how much paper there was. Because if there was only just a few sheets, then you knew there was a compile error in your program, and what that meant was you'd have to wait another half a day before you could. Every single compile error cost you a half a day because there was 2 runs in the day. So you were a lot more careful. I have to say, you were a lot more careful about how you wrote your programs in those days.
It sounds like a development with Angular website. It's so similar.
Yeah, I mean, you didn't think it was a nightmare in those days. You just thought that was how it was.
I have one question, because I saw already the holes, and I think I saw the more advanced holes, because what I saw back then as a kid, I was fascinated by that. There was like a paper roll with holes.
Punch paper tape. Paper tape was still around when I started. There was program computers. Like there was a very powerful computer, I remember, in a remote center. This was a very unusual thing, and that I can't remember where it was. An Atlas computer, but I can't remember where it was. And to program that, you did have to use punch paper tape. Punch paper tape was worse than cards.
Okay.
The worst thing that could happen with cards was you might drop the tray, and then your deck of your 500 line program, the cards would fall out in a random order, and you would just have to sort that by hand to put it back in the tray. That would be really bad news. But punch paper tape tore all the time. So you had to stick it together, and of course, when you stuck it together, then the holes would be out of alignment, and you had to use you had to stick it really, really carefully.
So is the tape predecessor of the cards?
Yeah, I think so.
Okay. So because I got such a roll, and I was fascinated. It's like, wow, it comes from computer. And I thought back then, I still remember, I was, I don't know, maybe 7 or 8. So, okay, one day I will understand the holes, And a few years later, I still...
Absolutely. No, you could read. I mean, I don't know whether I ever did it, but I could remember people holding the tape up and just scanning the holes, reading the ASCII characters off the arrangement of the holes, because they just knew off by heart which pattern of holes corresponded to which character.
Okay. One question is, who created the holes? Were you? Or, I mean, if you wrote a program, how you wrote it? So you had to create the holes,
in the punch paper tape. I guess. I mean, that I do not remember. I mean, I do remember the punch rooms. Where there were these people who were basically like typists who would coding sheet, and they would type onto a keyboard, and the machine would then punch the cards corresponding to your coding sheet. I think probably that that tape was probably punched in the same way, but I think I didn't use it enough to remember how that.
Okay, no. I was just curious to know how the holes happened, whether it was cards or tape. But who did it? What is the typist?
Oh, right. So what they had these people who were called punch operators, and they were always women, and it was a secretarial job, and it wasn't. It basically wasn't a very senior secretarial job. I mean, there were a lot of typists in those days.
So back then, every programmer had a good relation with a woman, right? Had to, because if the woman will introduce, an error, it's over, right? So
well, there would be 2 runs of the cards. So first of all, somebody would punch them, and then they would have a second run through a verifier to make sure that they hadn't made any mistakes in the typing.
Okay.
I'm astonished I remember this, by the way. This is
the
well over 50 years ago.
The EXFM effect. So podcast effect. Okay, so what happened then? So you got the computer. So what was your next language, maybe? Because you started with Pascal. So what was the next step?
So after that, I kind of knocked around for a bit. I mean, it had never occurred to me to. As soon as I do remember, it's quite a vivid memory for me. A person who doesn't have very many vivid memories. The first time I ever went to a lecture on computing, and it was an additional course for people doing the science subject doing chemistry. Because you might need to know how to program in Fortran, and I remember watching the lecturer introducing Fortran to us, and thinking, I wish you'd hurry up. This is really slow. Come on. This is obvious. And we came out of the lecture, first ever lecture on computing, first time I'd ever actually had anything to do with it at all. And most of the people around me that were on the same course were saying, "What was that about? I didn't understand a word of that. This was really difficult." And I realized there's something here that just makes sense to me in a very immediate way, in a way that it doesn't to other people. But I didn't pursue it for a while until I did various other things and knocked around for a bit. But I happened much later on in the maybe 2-3 years later, I found myself with an acquaintance who worked in one of the London universities, and I'd remembered how much I'd enjoyed computing, and I thought, well, maybe I ought to learn this, because at the time I was teaching and I wasn't enjoying it very much, and I thought, well, maybe let's try this computing thing. So he gave me a login.
What was the alternative? So what you did before computing? So you were the teacher just, or
I had a spell as a school teacher teaching science, but I fancied having a go at this programming thing, and I sneaked into the London college that I'm thinking of. I had a login. He gave me a login. He was a lecturer there. He gave me a login, and I remember what I was programming in there was in assembler. I have no idea why. For a while, because I'd learned Fortran, and that was kind of obvious what Fortran was about, I just couldn't understand what assembler was. Just the idea of machine code just hadn't come up ever. And I remember the kind of light bulb going on and thinking, oh right, I get this. This is quite cool. And for a while, I thought, like programming to the metal, writing in assembler. That's what a real man does. Yeah. I don't think I thought that, but it kind of felt like it was more real. So I really liked that idea. Mm-hmm. And I just started after that. I did some reading, and I just started applying for jobs as a programmer, and kind of not being completely honest about my experience. I don't suppose, kind of exaggerating and saying that that I'd learned more at university than I really had, and eventually I kind of bluffed my way into my first job.
Yeah, fake it then make it, right? This is what the others actually stolen from you from your strategy.
Right. That's right. Yeah. And that actually was programming in assembler. I spent 3 years.
Was it? It was not Motorola, right?
No. This was an absolutely quixotic project, which was actually under the auspices of the nationalized steel industry. At that time, the steel industry in Britain was still nationalized, and there was a very eccentric, quite senior person in the operational research area of British Steel. Operational research.
What means eccentric?
Eccentric. somebody who has ideas of their own, and eccentric means not conventional.
Yeah, this is, I know what it means by definition, but how to call it? How it appeared, you know?
How it appeared was, I mean, as far as I remember, I think he was a fellow, or maybe a distinguished fellow, of the British Computer Society, which means he must have done something serious in computing at some time. Operational research was really important. Obviously, it was very important to a steel manufacturer, and so it was important enough and big enough that there was research into how to do operational research better. Because this would save them a lot of money, and he decided that he needed a new language for operational research. Right? He was inventing this new high level language, and as far as I remember, there was an assembler which was also an invented language. It was sort of like bytecode, so that it would be very low level, but it would be easily translated into machine code for different architectures. But what we were doing was we were writing the compiler from his new high-level language into this assembler. And the problem was that he didn't have any idea at all about compiler theory. And yet, he was not a language designer. This was a guy who would drive from where he lived into the office and announce that he'd had an idea for a great new feature in the language. That was how much thought he'd had. He thought it up on the motorway to get there. I mean, if you think about how new language features evolve for Java now, I mean, it's...
this is like how Brian Gertz operates usually, right?
Sorry, say again?
How Brian Gertz operates, you know?
Well, that's exactly the contrast I'm drawing. You can't imagine the contrast. I mean, Brian, well, new language features gestate for years.
Yeah, exactly.
And this guy, his new language features gestated for minutes and minutes and minutes.
Yeah, and then agile, right?
Yeah, sorry.
This was agile.
This was indeed agile language design, and it was so agile that it would bend over backwards on itself. And the next week, he would come in and say, "I've changed my mind about that feature. Would you do some other thing?" And we would bend the compiler to. Well, you can imagine this project was not.
Yeah, there's a strong opinion loosely held, right? So this was. Okay, so you spent some time there. Only 3 years.
3 years, yeah, that's right. And it was really, it was bad luck really for me. It wasn't a place where you would learn an awful lot about good practice, because nobody there really. I mean, in retrospect, everybody was trying hard, but nobody really knew what they were doing. They really wasn't doing.
What happens afterwards?
What happened after that was I went to work for a friend had gone to work for again a sort of nationalized. I think it was still a nationalized industry. So my first two jobs, first 6-7 years of my life, working life, something like that, were in nationalized industries in Britain, because that's how it was then. This was a nationalized computer industry. It was called International Computers Limited, but it was the British computing industry. It was later bought up by. It was broken up, privatized and broken up not after I left, and a big part of it was bought by Fujitsu. And I don't know whether you've heard about the great post office scandal in Britain.
No.
Oh, this is enormous. Can I take a diversion to?
Yeah, absolutely. EHXFM is all about diversions. You know?
So the Fujitsu sold the post office in Britain, which again was a nationalized. I think still it may be privatized now, but was a nationalized company. So the post office, which is an enormous organization with sub post offices all over the country, like around every corner. And these are run by people. These are run on a franchise basis. They're run by postmasters, who are basically shopkeepers. But they're shopkeepers, and the shops often have other things in them. But they also sell stamps, and you can mail your parcels from them and so on.
Do they have the title postmaster?
They have the title of sub-postmaster.
That's a cool title, actually.
A postmaster and sub-postmistress. Well, the sometime, I can't remember when, maybe about 25 years ago, the post office introduced a system called Horizon The central post office introduced one, and this was a financial management system that balanced up the takings of the sub post of all these sub post offices, and worked out whether everything was in balance and whether the sub post masters and sub post mistresses were returning the same amount of money as the value of the services they sold. And immediately, the Horizon system started reporting discrepancies. And and prior to Horizon being reported, there were many hundreds of these people running these post offices that had never had any trouble. And suddenly, they started being reported for fraud. So Horizon was saying, your numbers don't add up. And the post office said, you've been stealing the money. You've been stealing money. Quite a lot of money in most cases. It was like tens of thousands of pounds. And hundreds of these people were prosecuted by the post office, private prosecutions. The post office has the ability. Not many organizations can do this in Britain. Basically, prosecuting people in Britain is a function of the state. But the post office was able to bring private prosecutions, and they persecuted these people on the basis that they'd stolen this money. And these people went to jail. In many cases, they were bankrupt. They were ostracized from their communities. Some committed suicide. It was all a lie, and they knew it was. And they knew from fairly early on there were suspicions that Horizon was buggy. And the people at the top fairly quickly knew that this was. The Horizon was basically a completely flawed system, and that the discrepancies that were being reported were not fraudulent at all. And they continued to prosecute these people, and they continued to send them to jail and to ruin their lives. I mean, it's just an extraordinary scandal, which is only recent. I mean, it was kind of known about from a long time back. The first reports of it that I remember were in a computing newspaper in the days when there were computing newspapers. So that's quite a long time ago now. And this thing bubbled away for a little.
What was the problem? Was it like grounding errors, or what's the wrong with the system?
Nobody knows. Nobody knows because it's all very secret. I mean, the only thing that we know is that one of the lies they told was that the engineers for the system could not intervene, could not actually access the operating system, the system while it was operating. And we know that was a lie. But other than that, we don't know what was actually wrong with it.
Sounds like early LLM integration, right?
right. Would you trust your entire life?
Yeah.
I mean, but I can't get over this. I mean, I'm sure it was very complicated, but the idea that it was completely impossible to test this and find out what was the matter with it, it's just.
What's strange is there was no system before, and now a system happens, and suddenly, that there is some suspicion that something is going south. So I would also test the system, right?
You would.
Why everyone trusted the system? This was a strange idea that the system is just perfect. So I mean,
but it's corporate culture. I mean, what you see is a group thing. They just. I mean, I suppose as soon as they started lying about it, as soon as you had some people who were prosecuted, and maybe to start off with, you're not sure. And then you've sent a few people to jail. And now there's questions, now there's questions about the system. And so what are you going to do? You'll double down because anything else. And so you just get into this situation. It's how wars go on. I mean, there are history books that describe the evolution of the Vietnam War, for example, in exactly these terms. From a long time back, the Americans knew that they were going to lose. But admitting it was always going to be more painful than going on another day, and the same way, let's ruin a few more lives, because actually admitting that we were wrong and rowing back is just going to be so painful that we'll just go on.
Yeah.
In the end, I mean, there isn't an end yet. I mean, there's still huge injustices outstanding, but there was a television program in Britain which really broke the story, even though many people had known about it. It took a television drama maybe about 18 months ago, and it absolutely this story dramatized. This program dramatized the story, and suddenly millions of people knew about it, and suddenly this thing that had been this huge injustice that many people had known about.
And it was revealed 18 months ago? not revealed, but there was the first, like bigger drama 18 months ago. It was like it went for years, right? The entire thing.
Oh, yeah, no, it had been going for many, many years. But the television drama really shot it. And suddenly it was impossible to. I think actually that there already was an official inquiry underway. But this television drama just suddenly it was like questions in Parliament and big headlines in the newspaper, and everybody knows about it now in Britain. It's really quite well known. But it took this television drama to do it.
Mm-hmm.
It was called The Post Office and Mr. Bates, if anybody wants to look it up.
Okay. Never heard about that, but it's a interesting sad story. But really, if a system is usually, introduced, no one trusts the system. So what's strange here, that they trusted the system more than the people before. So this was the interesting part, right?
Well, if you're interested, I'm sure there's a lot of material now available on the Horizon scandal.
Mm-hmm. But the name is cool. So if this would be not as evil as it was. So I mean, if you could extend your CV with postmaster at Horizon. This sounds great, at least in Germany, right?
Well, a job that I got very much more.
Why we talk about it? This was you had something to do with Horizon? No.
Oh, no, I didn't. I'm glad to say this was developed by a different part of ICL,
and maybe even not in Java, right? So
I don't know. I know for sure not.
No, for sure not.
I think it was developed many years after I left anyway. So and in a different part of the company. But
it was implemented by ICL.
It was implemented by the part of ICL that became Fujitsu.
Oh, okay.
Yeah. So I mean, everybody talks about Fujitsu now, and nobody remembers, or hardly anybody remembers, that was ICL before it became Fujitsu. Okay. Yeah, it was.
So, what do you do in ICL?
I worked on an operating system. Mm-hmm. It was actually this was the first place that I had a real job where people did know what they were doing, and it was very exciting. I mean, so I went there in 1977, I think. That's right. I was there for the back half of the 1970s and into the 1980s, and that was very exciting for me because I was actually programming in a language. Again, it was an ICL, a proprietary language called S3, which was based on Algol 68, and I still think that Algol 68 was a really good language. As you can tell how old I am, because obviously you can tell how old Algol 68 was.
What you should do is, you should, for instance, deliver a DevOps talk about Algol 68 without mentioning that it's that old, like the new thing, and sell it as a new language. I'm pretty sure, that people will just, because this is like a fashionable thing to do, just, pick whatever is not Java and just try to make it successful, right?
Yeah, absolutely. This is what I should do.
Yeah, it would be fun.
Right, it would be. And I don't know. I mean, I suppose I went to a talk on at GCon. I was at GCon in Krakow last week.
Yeah, we met there, right? And you remember me. So I tried to ping you, but you are, on so high status. So I don't read emails anymore, no LinkedIn, nothing. I tried to ping you, Maurice, come, we have to talk at the AirHacks. Like, no. And then we met, and then it works, right?
Yes. Not a matter of status at all, a matter of inefficiency.
Thank you for attending my talk, by the way. You attended my talk, right, at GCon? Yeah, thank you.
No. It's you're welcome. It was I enjoyed it very much. That's what I was going to say. At GCon, there was somebody was talking about computing history, mainly more in terms of hardware than software. Well, I have a flat that's filled with that kind of computing history, so I was really interested in this. I thought, maybe I can find some. I hate to throw out these old computers because I feel like I'm throwing out history. But talking to you, I realized that I'm actually a piece of history myself.
But it's very important because what I always appreciated is the experience from older programmers, and I tell you why. For instance, there was, as Java came out, there was a huge movement migrating away from host. From host, ZOS and AS400 and stuff like that, right? So, and host systems, ZOS and so forth. And I was just interested, is it possible, and how the old systems operated. And what I find out sometimes, like for instance, this AS400, so I had a chat recently with an architect in a company, So it operates differently because the database, and the transactions and the business logic are in the same memory. Mm-hmm. So if they operate in the same RAM, in the same memory space, of course you have less problems with two-phase commit and transactions and so forth. It just works. It's just, and if the machine is stable, it is unbeatable from performance and whatever, right? So if you try to tear it apart and do whatever you can do with Java, you have no chance to be successful. And therefore I had a nice, or maybe you remember the terms after image and before image. This was like yeah. And we do the same with JPA, with optimistic logs and so forth. So I have to say I learn a lot just listening to them, asking questions. I ask a lot of questions. So I would say history of software would be very valuable, software architecture maybe even, because for me it sounds like new programmers show up and they ignore the past, try to reinvent the future, and they are actually doomed to fail because they will redo the same failures we did. Sure. And this is a pity a little bit, because I think now is good time to introduce host-like systems. We say, okay, we have smaller things, everything in one piece. Maybe it should be like not as expensive as the host, just the same hardware, but operates in the distribution. Is not maybe the best thing to do. So this is why I think it's a good idea just to think about old systems, because they were actually good. So right, or still are.
Well, sometimes. I mean, there are some aspects of new systems which are much better. But
sure.
You're right. There are ideas.
But principles, the principles. Yeah.
Absolutely. Well, I mean, there is one interesting aspect to this, which is that people had to work with indescribably smaller hardware resources. And so, like the hardware 30, 40 years ago was so much slower and so much smaller than what we have now, that you had to be much more ingenious, and you could, and people thought really, really hard about packing instructions into the smallest possible space, and using minimal memory. And although some of that is unnecessary now, there's still quite a lot you can learn about the ingenuity. The people. I mean, some of the best algorithms were devised in order to get around those, to live with those restrictions. Yeah. No, definitely.
Perfect. So what was your next step? So you implemented the operating system, you said.
I was part of a pretty big team.
What was the name of the operating system?
The operating system was called VMEB, and nobody remembers that now, because it was for a proprietary architecture for ICL. But it was quite advanced for the time. And I mean, I don't remember very much about it, because I wasn't involved as an architect at all. I was a pretty low level programmer at the time. But the idea of it was to try to get a system that would be stable, in the sense of having there was layers of protection, which I think you now have with Intel chips. I think there's like there's kernel and there's user space, and I think
there are rings, they're like rings. I think
there's rings. I think for in Intel architecture, I think there's like 3 or 4 rings, something like that. VME had 15. I think it's 15 or 16 of them.
Okay.
And there was the software was privileged to run at one of these different levels, and the aim was to have a much more stable system than anybody had achieved until then. And
was it?
I wasn't there for long enough. I think it became more stable while I was there. I mean, frankly, at the time, I mean, my main memory of it was that if you wanted to do any programming, by this time we were off punch cards and we were onto green screen terminals. But there was still a real shortage of them. So for every 10 programmers or something like this, you would have one terminal. So you had to put your name on a list to get access to the terminal, and then wait an hour or something like that until everybody else had their shot. I think by this time, I think our programs were still being punched in. I think there was still a punch room in that place.
Okay.
I'm pretty sure, but by this time we had interactive terminals. But I do remember. I think the interactive terminals were probably there for testing. And what I remember was a system of traffic lights mounted on the walls of the corridors, and there was a red, green, and amber, obviously. Well, obviously for a British system, same as red, amber, and green. And red meant that the system downstairs had gone down. Amber meant that it was booting again. It was coming up again. Green meant that you could actually get some work done. And so watching these lights was kind of favorite occupation, because you're waiting to that you're not going to get onto the terminal until everyone in front of you in the queue has finished, and they're not going to finish until the lights are green. So you're possibly going to spend some time thinking. There was a lot of thinking.
We use traffic lights later for our Jenkins builds to indicate, the Jenkins build status. So, right. And in one company, they actually there were skilled developers, and they bought actually a traffic light, so it really looked like that. So it was interesting. Okay, so what happened after ICL?
After ICL, I went to teach in something happened while I was in ICL. I got involved. It's a sort of separate thing. I don't know quite how to describe it. I was kind of promising in some way that didn't have anything to do with my day-to-day work, and so I got sent on courses. And one of the courses I got sent on was for formal development, as we called it then. And so, I went on a course that was taught by Cliff Jones, who was one of the two people who'd really invented the Vienna Development Method, VDM.
Vienna
Development Method. It was called that because Cliff Jones and Dinas Björner had devised it while they were working at IBM's Vienna labs. And this was formal specification. Basically, it was a pre-post condition thing. So you specify what you expect your in Java terms, what you expect roughly your method to do, and the precondition is established in terms of formal first order logic, which connects all the variables of the input parameters to the method and the state of the instance variables, the state of the program, and it says the program is only expected to work if the precondition is satisfied. In other words, like if it's going to be, I don't know, supposing, for example, it's supposed to be, I don't know, working with people's ages, then you don't expect to get a negative age, that kind of thing. So I mean, but much more it can be much more elaborate than that. And so the precondition would then be connected with the postcondition, which is what the precondition is, what the program is entitled to expect in terms of the input parameters and the state, and the postcondition is what is required to establish. In other words, you're supposed to transform the state in a particular way, or return an output value, something like that. So, but the idea of this was that formal methods was all about how you actually write these specifications, and the idea was you would make programs more reliable if you had mathematically precise specifications.
They were incorporated in languages. I think Ada had this as well, right? It was built into Ada in some languages. No, not built in, not formal, but at least pre and post conditions. There's one, a famous language, an early one, which incorporated that. And on that note, Leslie Lamport also did this, right? Formal.
Yes. He was a big figure in this movement. I got really interested. I mean, I left ICL because they were going to send me on a master's to do a master's in this kind of thing at Oxford University, and then they just changed their minds, and I thought, well, I'm not going anywhere here because I really want to get into academic life. So I went to work as a researcher at Stirling University, and what I was interested there was taking these specifications, and there was a thing called stepwise refinement, which would enable you to take those specifications and by precise mathematical transformations, transform them into a program. So it wasn't like you wrote a program and then checked to see whether or not it matched the specifications. It was you used the specifications as a basis for building the program. That's the idea of stepwise refinement from formal specifications. But like it's very difficult, this stuff. I mean, in terms of, I know that academic research in this area has moved on a very, very long way since I was involved, but it's still not practicable for really large programs, unfortunately. And I'm I still have a bit of quite a strong feeling that programming should be about being precise, and you should understand the culture underlying formal specification is you should know exactly what's going on. In order to write, let's say, a loop invariant, you need to have quite a deep understanding of exactly what's going on in your program, deeper than programmers usually have. Or deeper than I usually have when I write a program without thinking hard about it.
But I think, this is a low level, but on higher level, in my project, it's always the case that at the beginning I only know a little. So I write a test with the assumption, and then learn as I go. So the program becomes more and more precise. So it's really hard at the beginning to start with specification, because even specification I recently had were incomplete, and they were just written without any thought, I would say. So what we even did, we wrote the program, and we found out that the specification is incomplete. So we created some, commits, and we refined the specification because it was incomplete. Right?
I think that's a really fair point. And there was certainly something about the culture of formal specification, the way I've described it, which derives from the way mathematicians like to present their work. And there's a very irritating thing. I mean, papers and discussions in formal specification in programming do follow this pattern, which I dislike, which is to make it look, mathematicians will very frequently present a proof of a theorem in the most really abstract and bare bones way. And the more you can erase your untidy thinking that reach this conclusion, the better. They want to pretend that they thought that they got the 10 steps that it required to get from theorem to proof, and they want to make it look as though they just thought those 10 steps out with no deviation and no mistakes and no blind alleys and no messing around and no actually refining the starting point. And the way I describe formal specification conforms to that pattern. And what you're talking about is much more the real process by which mathematical proofs and indeed actually formal development should work, which is it gets built up through mistakes and blind alleys. And what you care about is what I cared about, and this was what I tried to do when I was at Stirling, was to evolve some sort of way of accommodating this messy business just to ensure that at the conclusion of it you have something that you can verify. But to get there, it's not going to be this clean, abstract, formal way of proceeding. It's going to be like the human messy way of doing it. So I agree with you. And this is what I wanted to do at Stirling, was actually to have a more humanly friendly way of thinking about building mathematically precise,
interesting, actually. Interesting projects, really.
Yeah.
And instead of doing this, because of politics, I guess, or whatever, so you left ICL, right, and did something else.
I left ICL because I didn't think I was going to get a chance to. I wanted to get back into academic life. First of all, I went to Wolverhampton. That was where I got. That was, since you asked about my first computer. This is the first time I bought a computer, and then Wolverhampton. It was there was teaching and no research, so I moved on to Stirling, and I spent some time there.
But you are then professional already. So if you bought your first computer, you exactly knew what you are doing. I mean, like, you are pro, right? Yeah, you knew the formal methods. You were able to program in assembly. We learned. Pascal and Fortran.
Yeah, I suppose so. I mean, yes, I thought I was I was a reasonably good programmer at that time.
Yeah. And so what was your next computer then?
My memory, I don't know. I don't know what was the next one after that. By the time I got to Stirling, people were using, which is now quite a long time. Well, so it'd be after Wolverhampton, and people were using Macs, the very very early Macs. But I don't think I got one of those until later. I certainly was working on Macs from that time onwards. But did I own one? I can't remember. I got the first. I don't know that I've ever had a desktop Mac. I don't think I ever have. The first laptop I got was something called a PowerBook 100, which actually I found the other day. Right, I still got it. I mean, I've got it sitting out on a table in the next room. It's like so primitive. It's extraordinary. It's like this sort of, the screen on this thing is the size of a small tablet, and it's about 3 inches thick. I thought it was the best thing ever. The idea of a laptop computer was just so exciting. So I think I would have. I can't remember when the PowerBook 100 was a thing. But I think from then on, I think ever after that, I have had. Of course, I had Windows. I did have Windows machines, but they were mainly things like for the children to have their games on, that sort of thing. I've never really seriously developed on Windows machines.
And what you did with the laptop? So what was which programming languages you used, or
for some time? Well, so I actually found myself in the 1980s, so in the 1990s, sort of without a programming language, because Pascal, was gone away, and so had S3. I built a system to support the kind of ideas that I was just talking about. The ideas of humanizing formal development, and I built that system in something called HyperTalk, which then became AppleScript, and it's still around.
I wanted to say the HyperCards, right?
HyperTalk which was the language for HyperCard.
Yeah, exactly. You did it?
I did it. Yeah, I wrote quite a large system. Well, I mean, it wasn't. I mean, it wasn't a large system by today's standards, but it was probably thousands of lines of HyperTalk. It was. I mean, I thought the language was just fine, and because I was building a visual tool, it seemed like a natural thing to do to build it in a HyperCard. But it was agonizingly slow. I mean, it was just absolutely terrible. I actually used it as a teaching tool back at the college where I had first learned computing. I had first learned programming. Sneaking in the after hours all those years before. And I got an undergraduate course there, and I did this in my spare time when I was.
It's a great experience, right? As you remember, you were younger, and then you're teaching the same.
Yeah. Well, the place that I used to sneak into and work at the hours, and I came back in as a teacher for a while. Yeah, but this. So I actually found myself without. I mean, since HyperTalk clearly wasn't going to be the language of the future, in the 1990s, I actually really didn't have a language that I was very happy programming in. So when Java came along, this was 1996, I think. This just. I just jumped on it straight away.
Why you were fascinated by Java? Because it's strange. Because you had low-level experience. HyperTalk is also not Java. So why you like Java?
Well, because by this time, after Stirling, I went and worked in London. Again, it was supposed to be on formal methods, but it was for Lloyd's Register of Shipping. I was going to say a company, but it's not actually a company. It sort of is. It's an institution that certifies ships and aeroplanes and that sort of thing for safety. I mean, the name of it means they certified ships for safety, but they branched out, and so clearly starting to certify software was really going to be important. And formal methods I mean, if you really want to know that your software is really going to work, it would be nice to be able to prove it. And so they had a research effort in trying to apply formal methods to certification of software. And and at that time, I really was out of programming languages, because that was when I was using HyperTalk. HyperTalk wasn't going anywhere. And the language at the time was C++. I mean, if you wanted to be a programmer, and I wasn't going to, the Lloyd's Register of Shipping, it was clearly things were going astray in the research area. They weren't going to keep that going for very long. I needed a programming job, and I needed a programming language. And I could not like C++. I just couldn't. And I tried, and I just couldn't like it. So when Java came along, I thought, this is great. This is going to be a commercial language, and it's not C++. and I was very happy with that.
What was your first Java program you wrote?
First Java program I wrote? Well, I thought I was going to. This is embarrassing. I thought this is like the very early days of the internet, and it's, in the mid 1990s, it looked like software was being distributed on CDs, and I guess on CDs, not even on DVDs yet, and I had an idea that there was scope for some kind of a local information service. I mean, this might sound very pedestrian now, but I thought if you could actually have a program on your computer that would enable you to look to see where shops were and when they were open and what kinds of things they sold, and I thought we could put a database that had all this information onto CDs and distribute them for free, basically, and have it paid for by the shop owners. It was an idea which actually did turn out to have some legs, but not quite in the form that I thought of it. So you take everything for granted now, of course, that you can do this. But then it was kind of quite a strange idea, and people were not very receptive to it. But I wrote the program that would support the database there. I wrote that in Java.
Java 1.0. I guess.
No, it was past then. It was past that by then, and I didn't really. I mean, I did. But I think I only wrote toy programs in 1.0 and 1.1. I mean, I was already writing in that, but I don't remember doing anything very much until 1998. So Java 1.0 came out in 1996, 1.1 in 1997, but it really moved in with Java 2.
Yeah.
In 1998.
So funny story, CDs. So one of my first projects with Java was an e-commerce backend system. It was like selling goods over internet. Back then, with servlets, it was a huge servlet system, so large application, and the company wanted to sell this on CDs, of course. So, and we delivered the first version. And I remember the entire program in Java was it was less than 2 megs, everything, right? So it was a tiny, I guess even below 1 meg, because there were no external dependencies, just our code. And then we added Java, which was tiny back then. So JDK 1.7 was roughly 5 megs. So this was, the entire JVM. So the entire thing was 5 megs of Java and maybe... I'm way below 1 meg our program, and the manager said, "What is this?" So I mean, no one will believe we are serious, right? This is an enterprise shop; it has to be larger. And then it's like, yeah, he's kind of right, but what we can do? And then they generated PDFs or whatever. They were huge, and they fill up, the entire CD to look more serious. But they distributed actually the software on CDs. And this was a thing, actually, even 10 years later, I would say, right? Yeah. And I remember it was 2003. I was at the BA World in San Francisco, and I got the servers on CDs. I still have them, so they look nice, the CDs. It was a thing, I would say, last 5 years, maybe. there were no CDs anymore. Before that, everything was distributed on CDs.
Absolutely it was. But clearly, I mean that's right. But you're talking about distribution of software. I mean, the idea really of having a database of, say, like the local information, which changes very frequently, distributing that on CDs is
I would say is not as strange, because you could have the master data on CD and then sync over internet. You can apply patches via internet. So as a hybrid, it could fly, because
that's true. I hadn't thought of that. I mean, I don't remember thinking of that. And
this would be the next step, because I think the idea is appealing, because the internet back then was not as stable as now. And so if you have
slower and people
flying and whatever, and even if I have something on my laptop which I can use and I know it is not accurate, it's still better than completely relying on the internet, I would say.
Yeah, I guess. Yes, you're right.
So the idea was actually good, I would say. And
I mean, the problems weren't essentially technical problems. I mean, the problem was getting it off the ground. Eventually I worked out. I was originally thinking of running in Edinburgh, where I live, and I realised that probably that wasn't economical. You needed to go to somewhere with a much larger population. In order to make it fly, and Britain is a kind of odd place. It's very centralised. There's a whole bunch of sort of second level cities which have like a couple of million people, or 1 million people, or 2 million people. But there's nowhere there's intermediate between those places and London. London is the big centre of population.
Okay.
So it would have had to have been in London. And by the time I'd kind of got to think about it, the internet had become fast enough, and Google had become sufficiently dominant that,
Yeah, but even Apple Maps. So if I just open Apple Maps in some area, and iPhone asks me, should I download the map for you? I say always yes. Why not? Right? It's always faster than the internet.
Yeah.
I mean, this is not. Yeah, I would say. It's the hybrid is cool. You could cache data. You don't have because of latency go to the internet.
Absolutely. But I mean, the problem is if you're not kind of if you're not anybody in particular, you're not well known. You've got to persuade shops to give you their shops.
Yeah.
And other institutions. It's very, very labor intensive to gather data from people who don't particularly want to give it. I mean, they may well give it to you, but you're going to have to actually ask them for it. Nowadays, it's the other way around, because people know, because shops and museums and so on know that without a digital presence, they'll have no custom. They are very eager to establish it, but in the early days, it's the other way around. You have to persuade them, and that's very, very labor intensive. So you're going to need to have an army of people. You're going to need to raise the money to have an army of people gathering that data, and so that involves getting investors and stuff like that I was never at all good at.
Maurice, you are too interesting guest. So I will have to reinvite you back and fully focus on Java. Because what I also really enjoy, I have to say, I attended your talk, Devox talk, with Jose, exactly. And I really enjoyed that. And because it was like, it was, seems like, Jose and Jose knows you. It was like a good chemistry between both of you.
Yeah.
And it reminded me, with your accent, of course, a little bit, the old Top Gear,
Really?
Yeah.
Usually people say the Muppets, the two old men on the Muppets.
No, it was like, there was a back and forth, the arguing. I really like that. And it was a nice talk. It was Devox 2024. It's on the internet. It was like something with streams. I forgot the title.
I think it was about streams and collections, like which is the best.
Yeah, but it's like what happens if you do stream everywhere or something like this, right? So
yes, right. Yeah, that's right.
Something like this. This was a nice talk, so I enjoyed that.
Oh, thank you. That was an earlier version, actually, of the talk that I gave at GCon. I kind of updated it and put my own stamp on it for GCon last week.
Yeah, absolutely. Yeah. Thank you a lot, and I have to reinvite you back.
Well, thank you. Well, thank you very much. I really enjoyed. I don't know. I mean, I suppose it's a chance for an old man to ramble on about his experiences and back in the day and that sort of thing. But I've enjoyed it very much.
But this is the interesting part, because if principles remain the same, right? Even your CDs and caching. So how we will approach this, if you do everything in the remote, you are. And now in the web, there is a principle called offline first. So what they try to do is, even in the browser, to cache as much data as possible to be offline capable. I would say, and the CD is whether it's on CD or in browser cache, I don't care. It's just the same idea for me, right? So we can learn a lot from history, I would say.
Yeah. No, you're right, and I have to say I hadn't thought of it. I mean, I suppose for me, the pendulum swung very much back the other way. I didn't see the potential. I'm really very poor at technical predictions, and so I focused on the CDs for too long, and I didn't see how much faster internet communication would become, or how universal it would become.
But were you somehow successful, a bit at least? Were you a bit successful back then?
No, I never managed to launch it as a commercial.
Okay.
Commercial program.
So where people can find you on the internet if they would like? It is hard, I have to say, but let's go.
They just can look for my name. I mean, that's the simplest thing.
Maurice.
There are very few. I think 0 are the Maurice Naftalins.
Maurice Naftalins. Okay.
Let me just check that. Yeah, that's right. So yeah, it looks like I have a presence.
So you are the singleton, Maurice.
I am the singleton. Yeah, that's right.
Thank you a lot.
Oh.
And see you next time.
No, thank you very much. I've enjoyed it. I appreciate the invitation. I'm sorry I've been slow in taking it up, and I've really enjoyed talking to you today.
Thank you.
Bye.